wiring a standard duplex receptacle. That's a duplex receptacle. Remember, it has a top and a bottom, it has a hot side, a neutral side, and a ground screw. The receptacles we use nowadays all go inside of enclosed boxes. We call these, a slang term for it's called a J-box. This would be a single, this would be a double, has places for either two receptacles or two switches, or a switch and receptacle, or any two fixtures. When you're wiring in a house, the wire that we use pokes in the back. You knock out the little tabs, you run your wires in the back, and the wires stick out. You wire your receptacle, and if you remember the mounting screws, they mount here at the top and the bottom, and they hold it, receptacle or switch, in place in the box. We're going to do it outside of the box so you can see it in more detail. We have two pieces of wire here. They're both 14-2 Romex with a ground. I have one that I've put black electrical tape in it. This is to show the power coming into our system. So when power comes into a house, it goes in through a meter into the breaker box, sometimes called a switch panel. And power comes out of that switch panel and goes to your room, your receptacle, anywhere there is a receptacle. So that this black wire symbolizes the power that's coming from the service into your receptacle. The other wire that doesn't have any tape on it is for the power that's going to leave this receptacle and go down to another receptacle. You remember when you drew your wire runs on your plan, if you go from one receptacle to the next, you'd have power comes in the bottom, power comes out the top. The black wire is power coming in the bottom. The other wire is power coming out the top. Wiring receptacles are pretty straightforward. Pretty much the two tools you're going to need is a standard screwdriver, either a Phillips or a flat, and a pair of pliers. I prefer the needle nose pliers. Sometimes you can use your wire strippers, the end that grips. And it's a pretty simple process of just connecting the dots. First, we'll start with power coming in. Remember, we did cut strip bend. We're going to take our black wire, which is our hot wire, and go to the hot side. We've got the little bend in it. We loop it around it. If the loop is too big and it's kind of loose, you grab the ends with your needle nose pliers and you pinch down on it a little bit, and it'll tighten it under that screw. Now the wire must go around the receptacle clockwise. It must go around clockwise, because if it doesn't, when you tighten the screw, you will actually push the wire out from under it. Then it's a matter of screwing that one in. We go to our neutral side, and I have my neutral wire, the white wire, and if you noticed, it is bent counterclockwise. So I just physically take it with my fingers and bend it around the other direction. Go in behind the neutral screw and tighten it down and ensure that it's clockwise. I haven't connected the ground yet because you'll see here in a second. So now I have the wire that's coming in power, coming from the service panel into the bottom end of the receptacle, and we're going to do our receptacle so they orient kind of in the smiley face position. Now I'm going to take my other wire, which is the power going out. I'm going to connect the hot screws using my pliers to pinch it down, pinch the loop down a little tighter so it fits a little better underneath it. It's less likely to come loose, because if you have a loose wire, you end up with what's called an arc, sometimes called a spark. If you've ever heard wires sizzling in the wall, or popping in the wall, I'm going to do the neutral wire, the white wire. I have to bend it around so that it goes clockwise, loop it behind the screw. So you got the sizzling sound in the box. You hear them in breaker boxes, switch panels too. It means something's loose in there, and if there's any space in here, the electricity is going to jump across it, and it's going to sizzle and pop. When you get an arc, you get heat. When you get enough heat, you get a fire. And when you get fire, your baby sister gets burned up and killed in the house. That's when you hear a fire that killed somebody and it was caused by electrical fire or electrical short. That's what it means. Now I'm left with my two ground wires. I haven't attached them yet. The grounds, all they have to do is physically touch each other to transfer electricity. So I twist them around each other. I'm just going to bend one end. I'm going to leave one end sticking out. And I'm actually going to put my bend in the ground wire that I didn't have before. Make sure it's clockwise. Loop it around the ground screw. And sometimes you can identify the ground screw because it's green, and a lot of times you can identify it because it's all metal. It's the metal screw touching the metal bracket, touching the metal fins, touching metal everywhere. That's generally the ground screw. This one has to pinch under a little bit. Tighten the ground screw. And now we've completed the circuit. We have the power coming in from our supply box, goes into the bottom two screws, hot on the hot side, neutral on the neutral side. We have power going out to another switch or receptacle, hot on the hot side, neutral on the neutral side. Make sure that wires are turned around and show me that you have them on there clockwise. Show me where you twist your two ground wires together and then one of them attaches back to the ground screw. That's what it should look like when you get finished. Please note and show me the path of your wires to where I can see them. And if you would, video yourself doing this, narrate, and tell me what you did. Tell me how things are bent and turned in the process, and show me which one's your lead wire coming in, show me which one's the wire going out, and show me how you connect the whites to the neutrals and the blacks to the hot and the bares to the ground. Upload that to Google where you found this assignment.